Hello, in this video we're going to see some representations of binary trees. So because a tree is also a graph, representation for graphs is in general can also be used for trees. Binary trees, however, have special characteristics that we want to capture in the representation, namely the identity of the left and right child. The equivalent of an adjacency matrix in two columns array or an array of record where the data for each node is the left and right child of that node. The equivalent of the adjacency list representation is a collection of records, three fields containing respectively the current node, a pointer to the record, and the left child node, and a pointer to the record for the right child node. So let's see. It's very simple. The tree represented by the figure has the array representation. So here is a tree, binary tree. So the root is 1, it has 2, 3, 4, 5. So we could represent it this way. The root is 1. It has a left pointer and a right pointer. The left pointer is pointing to 2, the right pointer pointing to node 3, and so on. If node 3 has no left child, so therefore it has no arrow, it's just a null pointer here, just a dot. And respectively, we could say that here are the nodes. We have 6 nodes, 1, 2, 3, 4 to 6. And so node 1, who's the left child and the right child, and so on. So you could do this. So this is one way of representing binary tree. So let's see this example. Write the left child, right child array representation for the binary tree in the figure. So here are the nodes. It looks like we have 7 nodes, and we're gonna write left child and the right child. So the root, which is 1, has 2 as a left and 3 as a right. And the node 2 has no left, but it has 4 as the right. And node 3 has 5 as the left child and 6 as the right child. And for 4 has a left child, which is 7, but no right child. And these are leaves, so they have no children. And this is the array representation. So let's see this example. You could stop the video and attempt it yourself. Draw a binary tree representing, draw the binary tree corresponding to the left child, right child representation. So here what we have is the array, and we need the tree. And what we need is the graph. So the root is 1, and it has left child 2 and 3. For the node 2, it has the left child as 4, no right child. And 4 has 6 and 7, but 3 has only 5. And that's it. This is the graph representing this array. Here is another example. It's a little bit different. So these are the nodes 1 to 6, and you have a left child, but you don't have the right, but we have the parent, and 1 is the root. So take a moment and try to draw this graph. 1 is the root, so the left child is 2. Of course it has no parent because it is the root, but for 2 it has left child, that is 4, and the parent is 1. And 3 has no left child, but the parent is 1. That means 3 is here because the parent is 1. And 4 has no left child, but the parent is 2, as we know. 5 has no left child, but the parent is 2. That means 5 should go here. And 6 has no left child, but the parent is 3. That means 6 should go here. So here is the binary tree represented by this. Try this question here, where we need to draw a full binary tree of height 2. And the question is, how many nodes does it have? And then you draw a full binary tree with the height 3. And how many nodes does it have? And for C, we need to make some educated guess. If a binary tree has a height h, how many nodes does it have? So take a moment and try this. So from previous video, we've seen that a full binary tree, like this one here, with the height 2, so this is the depth of the node is 0, 1, depth 2. So the number of nodes we have, the total, we have 7 nodes. And similarly, we're going to draw one with the height 3. So the depth is 3 and the height, so the height is 3 and the number of nodes, if you count all of them, it looks like we have 15. So now the conjecture would be what? So the conjecture here, a full binary tree of height h will have a total 2 to the power of h plus 1 minus 1 number of nodes. So let's see here. So this is height 2, 2 to the power of 2 plus 1, that is 2 to the power of 3 plus minus 1, so it's 8 minus 1, and that's why we have 7. Here the height is 3, so it's 2 to the power of 3 plus 1, then minus 1, which is 2 to the power of 4 minus 1. It's 16 minus 1, and therefore it's 15, and so on. This is not a proof, but just an educated guess. You could use proof by induction to prove that it's true.